Hi, I'm Jessica Zhu, and this is my video for midterm 2. In part A, I plotted the equipotential lines. To do so, I converted the electric potential constant values that were given and converted them from polar to Cartesian. And this gave me figure 1 here. In part B, I calculated the x and y components of the electric field. In order to do this, I first converted the V, which is the electric potential equation, from polar to Cartesian. And then to find the x component of the electric field, I took the negative partial derivative of V with respect to x. And to calculate the y component of the electric field, I took the negative partial derivative of V with respect to y. Here in my command window, Ex is the x component of the electric field and Ey is the y component of the electric field. And as I scroll, this is the whole differentiation. Then in part C, I plotted the electric field lines based off of the Ex and Ey I calculated from part B. This can be seen in figure 2. If I zoom in to the center, you can see that there is a small gap in the middle, signifying that the centermost lines aren't actually connected. In part D, I superimposed the electric field lines and the equipotential lines. This is shown in this figure 3 here. As you can see, there are 4 point charges. The first point charge is located here where my cursor is, since this is where the inward pointing electric field lines stem towards, as well as it is near the center of the smallest innermost equipotential line for this point charge. And this point charge is negative since the electric field lines are pointing inwards. The second point charge is located here, again, where my cursor is, and this is a positive point charge since all of the electric field lines are pointing outwards from this point. The third point charge, again, where my cursor is also positive, as indicated by the outward pointing electric field lines. And finally, the fourth point charge, again, where my cursor is, has electric field lines pointing inwards, indicating that it is a negative point charge. This graph is to be expected since all of the electric field lines are perpendicular to the equipotential lines. In addition, as you get closer to each point charge, the equipotential lines are closer and closer together. And this signifies an increasing magnitude of the electric field the closer you get to the point charge, which is to be expected.